Okay, so here's our third and final example. Pause this and have a quick read through it. Okay, so this one's similar again. The difference here is that it brings a smooth hinge into the question, and we'll have a look at how that affects our working. So, what we've got then, we've got a uniform rod, AB, smoothly hinged at A, and it's held in equilibrium in a horizontal position by this string attached at C and D. This angle's 40 degrees. So that's our diagram of what's happening. So if we turn it into a force diagram, we've got the weight of the beam, we've got tension in the string, and this is where we now look at the smooth hinge. So if it was just resting on the wall, we'd have a single normal reaction perpendicular to the wall, but because it's smoothly hinged, the force can actually act in any direction. The best way to deal with that is to label two forces, one horizontal and one vertical, and then we can work them both out, and if we need to, we can combine them to get a single answer at the end. Okay, so part A wants the tension in the string. So again, the three tools that we've got are up equals down, left equals right, and moments. Here, the best approach is going to be to take moments about A, because that lets us eliminate X and Y from our working. So moments about A. Easy one first, force 6G times perpendicular distance 2 meters. That's our clockwise moment. Now our counterclockwise moment is provided by the tension, so the force is the tension. Now this one's slightly trickier, the perpendicular distance from A to the line of action of this force. So the line of action of the tension acts through the string, so if we draw on, there we go, the perpendicular from A to the line of action of the force, this is the distance that we want, this dotted line. Now that's not too tricky to work out because we know that the hypotenuse of this right angle triangle is 3, so it's going to be 3 sine 40. There we go. So if we just put that in to our calculator, we're going to get the tension. So 12G divided by 3 sine 40 gives a tension of 60.98 newtons, or 61.0 newtons, to 3 significant figures. Okay, so part B wants the magnitude and direction of the force exerted on the rod by the wall. So in this case we need to work out both X and Y. Then because it asks for the magnitude and direction of the single force, we're then going to combine them at the end. So if we do, let's do right equals left to start with, you can see that X equals T cos 40. So X is simply answer times cos 40, which is 46.7 newtons. And then if we do up equals down, you can see that Y plus T sine 40 equals 6G. So Y is 6G, subtract 61.0 times sine 40, which is 19.6 newtons. Okay, we're basically done. Just to finish the question off then, they want the magnitude and direction of the force. We've got the horizontal and vertical component. So if we draw it like this, our horizontal component is 46.7 newtons, vertical is 19.6 newtons, and this is the force that we actually want. So this is the force that acts at the hinge as a single force. So we can work that one out using Pythagoras. So the magnitude of the force is the sum of 46.7 and 19.6 squared square rooted. Which is 50.6 newtons. And then the direction, which we can work out, I've labelled it as theta. We can say that theta is going to be arctan of 19.6 over 46.7. So that's 22.8 degrees. And we'll say that's above horizontal. Okay, so that's all of our examples done. 3 different ones showing a few different elements. That should be enough really for you to have a go at the questions. So please have a go at the questions, send me your answers, and I will mark them and get back to you. I hope those made sense. If you do have any questions, please let me know.